Students who have mastered Level A and the composition of the numbers 11 through 20 are ready to learn difference and distance within 20. As we saw in Stage 3, difference refers to the meaning of subtraction in numeration. We can model differences within 20 on two MathRack number grids. In the top MathRack number grid, we have 12. In the bottom MathRack number grid, we have 8. So we are looking for the difference between 12 and 8. We can see that in both MathRack number grids, we have a block of 5. So let's remove that. Then we can see that we have 1, 2, 3 more counters that are the same. So let's remove those. And now we are left with the counters that are different. We can see that we have 2 and 2, so we know that the difference between 12 and 8 is 4. We want students to notice that these two are needed to get from 8 to 10, and these two are needed to get from 10 to 12. In this way, we can use 10 to find the difference between 8 and 12. Now we have 13 in the top MathRack number grid and 9 in the bottom MathRack number grid, so we are looking for the difference between 13 and 9. Again, let's take out the 5 that are the same, and now we have 4 more counters that are the same. Let's remove those. And we can see that we are left with 1 and 3, so the difference between 13 and 9 is 4. Again, we need this 1 to get from 9 to 10, and these 3 to get from 10 to 13. In this example, we are looking for the difference between 14 and 10. Now, we have 10 in both the top and the bottom MathRack number grids. So those are the same, and we can remove them. We can see that the difference between 14 and 10 is the same as the difference between 4 and 0 when we take out the tens. We can use this strategy whenever we are looking for the difference between two numbers that contain a 10. For example, if we are looking for the difference between 15 and 11, we can remove the tens and see that it will be the same as the difference between 5 and 1. When we take out what is the same in 5 and 1, we know that that difference will be 4. We now have two decomposition strategies for using 10 to find differences within 20. First, let's consider the case of finding the difference between a number that contains a 10 and a number that does not contain a 10. For example, the difference between 13 and 7. If we take out the parts that are the same, we can break what is left down into two pieces. The first piece is the part that is needed to get from 7 to 10, and the second piece is the part that is needed to get from 10 to 13. When we put these together, the difference is 6. Second, let's consider the case of finding the difference between two numbers that both contain a 10, such as the difference between 19 and 13. In this case, we can remove the tens and see that the difference between 19 and 13 is the same as the difference between 9 and 3, which we should already know will be 6. These decomposition strategies may become more clear when we consider distance, or the meaning of subtraction in magnitude. Consider, for example, the distance from 8 to 13. We can see that the distance from 8 to 10 is 2, and the distance from 10 to 13 is 3, so the distance from 8 to 13 will be 5. Or consider the distance between 12 and 17. On the number line, it is easy to see that the distance from 12 to 17 will be the same as the distance from 2 to 7, which is 5. As we saw in Stage 3, students who acquire a deep understanding of the meaning of subtraction in numeration, or difference, and in magnitude, or distance, will have an advantage in solving a wide variety of word problem types. Let's consider a comparison problem where the difference is unknown. Ahmad has 17 cookies and Michaela has 13 cookies. How many more cookies does Ahmad have than Michaela? We are being asked for the difference between 17 and 13. We know that we can remove the tens, and this difference will be the same as the difference between 7 and 3. So Ahmad has 4 more cookies than Michaela. Now let's consider a comparison problem where the smaller quantity is unknown. Ahmad has 4 more cookies than Michaela. Ahmad has 12 cookies. How many cookies does Michaela have? This is a trickier problem, but we can recognize that again we are being asked for a difference, the difference between 4 and 12. We know that the difference between 4 and 10 is 6, and we need 2 more to get to 12, so Michaela must have 8 cookies. Now let's consider some separation problems. First, we'll consider a simple takeaway problem. Ahmad had 18 cookies. He ate 4 cookies. How many cookies does Ahmad have now? This is 18 take away 4, or the difference between 18 and 4, which is 14. Now let's consider a separation problem where the change is unknown. Ahmad had 15 cookies, but he ate some of them. Now he has 9 cookies. How many cookies did Ahmad eat? As we saw in Stage 3, in this type of problem, what has been taken away is precisely what we do not know. However, we are still looking for the difference between 15 and 9. We know that from 9, we need 1 to get to 10, and 5 more to get to 15, so Ahmad must have eaten 6 cookies. Now let's consider a join problem where the change is unknown. Michaela had 13 stickers. Her teacher gave her some more stickers. Now she has 20 stickers. How many stickers did Michaela's teacher give her? We are being asked for the difference between 13 and 20. If we take 10 out of both numbers, we know that the difference between 13 and 20 will be the same as the difference between 3 and 10, which is 7. So Michaela's teacher gave her 7 stickers. Now let's consider a problem where the initial quantity is unknown. Michaela had some stickers. Her teacher gave her 3 more stickers. Now she has 11 stickers. How many stickers did Michaela have at the start? Again, we can see that we are being asked for the difference between 3 and 11. We know that we need 7 more to get to 10 from 3 and 1 more to get to 11, so Michaela had 8 stickers at the start. Finally, let's consider a part-part-whole problem where a part is unknown. Michaela has 16 friends in her class. 8 of her friends are boys. How many of her friends are girls? We are being asked for the difference between 16 and 8. We know that we need 2 to get from 8 to 10 and 6 more to get to 16. So 8 of Michaela's friends must be girls.